Hi everybody, I took my picture off so that you don't have to look at me during the lesson, but I'm going to try to walk you through part 2 of two related quantities. This is lesson 17. So when you are on the page, it should look like this. Walking to the library. Well, your page doesn't look like that. Actually, your page looks like this. Okay, so Diego, Lynn, and Jada each walk at a steady rate from the school to the library. Lynn can walk 13 miles in 5 hours. And we're going to make a little table here. It says to do a table or a graph. So I'm going to do a table. And Jada can walk 25 miles in 10 hours. Okay. If they each leave school at 3 o'clock and walk 3¼ miles to the library, what time do they each arrive? So the first thing you need to do is find out the unit rate. So for Lynn, you're going to divide how much does she walk in 1 mile? And so you're dividing each side by 5 to get the unit rate. So 1 mile would be 5/13. And then you're going to multiply that by, so our total miles that we want to go is 3¼ which as a improper fraction would be 13/4. And you're going to multiply that by 5/13. So if you're multiplying, let's come back to my page. You're multiplying 5/13 by 13/4. And if you're cross canceling, these 13s are going to cross each other out. So your answer for this one is 5/4. And 5/4 of an hour. So 1¼ hours or 1.25. How long it takes to go to the library. So if they leave at 3, 4¼ would be 4:15. And if Jada is 25 miles in 10 hours, then in 1 hour you're going to get 25/10. Or you're dividing it by 10, so you're going to get 10/25 of an hour. And if you're multiplying 10/25 by, again, the total 13/4, you're going to get 130 over 100, which is 13/10, or 113. So it takes her 1.3 hours, which is 1 hour and 18 minutes. So she arrives at 4:18. So Lynn arrives at 4:15. Jada arrives at 4:18. Okay, so moving on, just to make sure you got that so the last column will be 13/4. That's the distance you need to walk, and it would take 130 over 100, which is 1 hour and 18 minutes, or 3/10 of is equal to 18 minutes. All right, going on in the table below, 17.2, the walkathon. All right, so Diego, Elena, and Andre participated in a walkathon to raise money for cancer research. They walked at a constant rate, but their rates were different. Complete the table to show how far each participant walked during the walkathon. So Diego walked 6 miles in 2 hours. And if you double that, you're going to double this. So in 4 hours, he can walk 12 miles. And if he does 5 miles, what are you multiplying by? So you're multiplying 2 by 3 to get 6, 4 by 3 to get 12, 5 times 3 is 15, and 1 times 3 is 3. So in the next section, for Elena, walked Okay, so if you're doing, let's do Elena's column, and if you divide 11 by 4, you're getting 2.75. So we're going to multiply that by each number. 1 times 2.75 is 2.75, or 2 3/4. If you multiply 2 by 2.75, you get 5.5, or 5.5. And if you multiply 5 by 2.75, you get 13.75, or 13 3/4. Okay, so now we need to do the same thing for Andre. If we multiply 17.5 by 5, you get 3.5. So we're going to start by multiplying that by 1, you get 3.5. Multiply it by 2, you get 7. Multiply it by 4, you get 14. All right, so then at the bottom, how fast was each participant walking per hour? So you're just looking at the unit rate. So Diego is walking 3 miles per hour. Elena is walking 2.75 miles per hour, and Andre was walking 3.5 miles per hour. And how long did it take each one of them to walk 1 mile? So Diego walked 1/3 of an hour. Elena walked 4/11. And Andre walked 2/7. Per hour. So to walk 1 mile, 1/3 of an hour would be 20 minutes. Okay, so if we're figuring that out, you're going to divide how much of the hour it is. So 1/3, 1 divided by 3 times 60 is 19.8. 4 divided by 11 times 60, because there's 60 minutes in an hour, so 21.81. 2 divided by 7 times 60 is 17.14. And that is the amount of minutes it took them to walk 1 mile. Okay, so in the next part it says graph the progress of each person in the coordinate plane. Use a different color for each participant. So you're going to use the chart we just did to graph each person's progress on the graph in your textbook. So you're doing that here. All right, so I would pause right now and see if you can do that using the table we just filled out on the last page. Okay, so if Diego is walking in, here's your hours on the bottom, here's your miles on the side. So if he walks 1 mile, 1 hour, he walked 3 miles. And then in 2 hours, he walked 6 miles. And in 4 hours, he walked 12. It'll be there. So I'm looking here for the 4 and over here for the 12, and you put a dot where they meet. Okay, and then in 5 hours, he walked 15. All right, so that's Diego's. Then we're going to use the chart to do Elena. So in one hour, Elena walked 2.75. So you're going to, it doesn't have that exactly on the graph, but it's almost at 3, right? And then in 2 hours, Elena walked 5.5. So right in the middle there. In 4 hours, she walked 11. And in 5 hours, she walked 13.75. And my red one should have been here. Okay. And then for Andre, I'm going to use green. And Andre walked 1 hour. He walked 3.5. And in 2 hours, he walked 7. In 4 hours, I erased mine. All right, so in 4 hours, he walked 14. That's right there. And in 5 hours, he walked 17.5. Up there. So you can see that these lines are going in a way that you can connect them, right? And that's important when you do these kind of graphs to see that, because if it's a constant rate, then it should go up at a constant elevation on the coordinate plane. Okay, so in answering the questions down below, it says Diego says that D equals 3T represents his walk, where D is the distance walked in miles and T is the time in hours. Sorry. Okay, so explain why D equals 3T relates to the distance Diego walked to the time it took. Well, so for every mile, it was multiplied by 3 to get how long it took, and T is the time. So Diego walks 3 miles per hour. So you're just multiplying the number of hours by 3 to find his distance. All right, in B, it says, write two equations that relate distance and time, one for Elena and one for Andre. So if it's distance is equal to 2.75 times the time for Elena, and for Andre, the distance equals 3.5 times the time to get the distance. All right, so on number 6, it says use the equations you wrote to predict how far each participant would walk at their same rate in 8 hours. So we said the Elena's was distance equals 2.75 times the time. The time is 8 hours. So if we multiply 2.75 times 8, D is equal to 22 miles. And for Andre, his was 3.5 times the time, and the time is 8 hours again. So if you multiply those together, you get 28 miles. Okay, and for number 7, in Diego's equation, so we said Diego's equation was D equals 3T. So the input is your independent variable. Independent. So the time is the one you input, and the output distance is the dependent variable. In other words, that how far you travel depends on how much time you're walking. All right. So are you ready for more? That will be in Seesaw. Okay, so today's goals were to create tables and graphs to represent the relationship between distance and time for something moving at a constant speed, and to be able to write an equation with variables to represent the relationship between distance and time for something moving at a constant speed. Okay, so Cool Down is going to be posted in Google Classroom, and Are You Ready for More is posted in Seesaw. And then you're supposed to do all of the problems from Lesson 17 practice problems. The answers will be posted the following day. All right, thank you.